Today, we're going to be learning about water quality indicators. As you go through this PowerPoint, make sure that you're taking notes on the page that looks just like this. Let's go ahead and get started. Water quality testing is an important part of environmental monitoring. When water is poor, it affects not only the aquatic life, but the surrounding ecosystem as well. I want you to think. Imagine different bodies of water if you've seen. Can you tell the quality of the water just by looking at it? Take a look at this picture. What do you think the quality of the water is? Is it healthy? Could you swim there? Are there lots of animals? Is it a thriving ecosystem? Take a look at this state park. Is the water healthy? Are there lots of animals? Could you swim in it? What's the difference between these two pictures? The answer is that we can't tell the quality of water merely by looking at it. Let's consider some of the possible sources of pollutants. Many of the most common pollutants come from one of two places, humans or animals. Human fecal matter, that's poop, in bodies of water is the greatest public health threat because humans are reservoirs for bacteria, parasites, and viruses that are dangerous to other humans, and they can cause a variety of illnesses. Runoff from agricultural land is also a serious health concern. Animal fecal waste can contain many pathogens like salmonella. Pet waste also can pose health threats to humans. Did you know that a single dog feces contains more than 40 million bacteria, and it's equivalent to nearly 7,000 bird droppings? Pretty disgusting. So when we think of all of the different ways that humans impact our water, even runoff from fields, lawns, and parking lots can wash directly into nearby waterways when it rains. It can carry with it any pollutants that might have been on the land. Even washing your car or watering your grass can carry potentially harmful pathogens into the water. The most common illness arising from contact with polluted beach water is gastroenteritis, an inflammation of the stomach and the intestines that can result in vomiting, diarrhea, cramps, and fever. You can also see things like rashes and infections of the ear, your eye, your nose, and throat. It's very important that we monitor the quality of our water and our ecosystem to keep our humans and animals safe and healthy. Consider this scenario. You have a pond on a piece of pasture land near your house where you love to go fishing. Recently, you notice there's a large amount of green film forming on the surface. When you disturb the green film with a stick, you notice that a few fish are floating on top of the water. What do you think is happening? Why do you think this is happening? What can you do to prove it? Well, this is a question that you should be able to answer by the end of this screencast. What can we do to prove it? Well, we can do some water quality testing. Today, we're going to talk about some different indicators that we would look at as we do our water quality testing. The first one we're going to look at is the amount of dissolved oxygen in the water. Dissolved oxygen is just like it sounds. It's oxygen gas dissolved in water. Now, most aquatic organisms need a measurement of at least 5 to 6 ppm, which we call parts per million, to survive. If you look at the range of dissolved oxygen, you can see that striped bass need 5 to 6, white perch 5 to 6, and then we start to get to things like worms and spot, 2 and 1. So most of our fish that we would eat need that higher level of dissolved oxygen. Now, what's going to make the dissolved oxygen higher or lower in certain areas? Well, there's 4 main things that can affect it. The very first is the temperature. Okay. Second, decaying organic material in the water. Third is the stream flow. And lastly is human activities. If you take a look at this probe, this is similar to the type of instrument that we'll be using when we do our water quality testing. If you take a look here, and you can see on this paper that oxygen gets into the water by doing things like mixing with the wind, waves, currents. That adds the oxygen from the atmosphere into the surface water. We also have plants and seagrasses, and they add oxygen into the water as well through photosynthesis. Now, mixing with river and ocean water can raise the level and lower the level of the amount of oxygen. If you look at this paper here, you can see in the picture that there's things that also remove dissolved oxygen. Number one, respiration and the breathing from animals. They're using that oxygen. When organic matter, things like poop, dead phytoplankton cells, plants, animals that have fallen to the bottom of the surface waters, when those things start to decay, they also remove oxygen from our water. The second level that we look at is the level of nitrates. Nitrates are a primary plant nutrient. Only a small amount of nitrates is needed when we're using plants. Nitrates are found in things like your fertilizers, they're found in compost, they're found in industrial wastewater. Might affect it as well. So if you think about nitrates as a fertilizer or something you would find in fertilizers, excess nitrates can cause something called an algal bloom, which basically means making the algae very, very rapidly expand. Essentially, you're fertilizing the algae, right? And we don't want algae because the more algae we have, the lower the water quality can be. So an algal bloom is defined as a rapid spread of algae. Take a look at this picture here. That's not a beautiful green golf course. That's actually a lake that's covered with algae. So if we're testing our water, we want to make sure that the levels of nitrates are going to be acceptable. The level should stay below 1 gram per milliliter for normal plant growth. The higher the level of nitrates, the better the chances are that organisms will die. Well, how do these nitrates get into our water? Number one, they can come from agricultural runoff. They can come from animal feedlots, lots of animals eating and pooping in the same place, right? And industrial wastewater. Animal waste has a really high level of nutrients in it. Poultry and hogs have very, very high nitrogen waste. And there's a lot of things that farmers do to be able to control the nitrates and keep them out of the waters and to prevent this. One of the things that they can do is compost their waste. Another thing is just to contain their waste. They will have an area like a sewage system for animals where the urine goes into, and bacteria breaks down that bacteria in the urine and in the fecal waste. Also, farmers are very cautious not to over-fertilize their fields. Number one, not to waste the fertilizer, but we know that more is not always better. And lastly, farmers test soil in their fields to see what type or how much, if any, fertilizer is actually going to be needed. I'm sure a lot of people have heard of pH. pH is the measure of how acidic or how basic a substance is. If you take a look at this picture, you'll see that the pH runs from 0 to 14. Between 0 and 7 is an acidic substance, and between 7 and 14 is more basic. You'll see some examples there. 7 is considered neutral. Well, if you have a pool or if you have a fish tank or a hot tub, you might have to test the pH, and you use these simple little pH test strips. When you test water for pH, most organisms need to be within a pH range of 5.5 to 9.5. As long as they're within those levels, it's acceptable. So, what are some things that might change the pH and bring it into levels we don't want to see? Well, number one, it can be affected by acid rain. Okay. Also, algae blooms and releases from industry. Along with phosphates comes another primary plant material. It's called along with nitrates comes another primary plant material, and that's called phosphates. Again, only a very small amount of phosphates are needed in your plants. Excess phosphates, just like nitrates, can cause algal blooms, and that reduces the water quality. Okay, those algal blooms start to take in some of the oxygen that we would want to have in the water for our living organisms. Now, when we're measuring phosphates, an acceptable level is below 0.1 milligrams per liter. Anything higher than that are going to cause our organisms to die. Very similar to the nitrates, phosphates are affected by agricultural runoff, urban runoff, so runoff from your streets and your cities, animal feedlots, and industrial fertilizer. So, for example, when you apply fertilizer excessively or before a rainstorm, it can wash off the lawn and get into your gutter. Then it can get into the storm sewer system and then into our rivers or lakes. Once the water has those extra nitrates, remember they have the same effect on algae as it would have on lawn. They make it grow. We know overgrown algae can have a devastating effect on a lake or a stream. It can consume all the oxygen and essentially suffocates the fish and other wildlife. Take a look at this picture here. What do you think will happen if algae and plants overpopulate a body of water? On to our next indicator, temperature. Temperature is very important in the water in our ecosystem. Most aquatic organisms live within a range of 32 to 90 degrees Fahrenheit. That's the same as 0 to 32 degrees Celsius. Remember, water has a high specific heat, so it takes a lot of heat energy to change the temperature, and it changes very, very slowly. This is a really good thing because rapid temperature change and extreme temperatures can really stress out aquatic organisms. If you're someone who owns fish and has a fish tank, you would know how this works. When you get a new fish and it's in its little bag, do we immediately dump the fish into the new fish tank to meet his friends? No. That fish has to stay in the water and in a baggie. And it stays in there until it assimilates with the temperature of the fish tank so he can get used to it. Otherwise, we find our poor fishy doing the backstroke. Well, what are some things that might affect the temperature in the water? Very simply, the air temperature, of course, over time, warmer days, is going to make our water warm up. The amount of shade an area gets will affect the water. And soil erosion. I want you to take a look at this graph here. If you look at the graph, you'll notice we're measuring dissolved oxygen over different times of the year. Winter would represent a cooler temperature. Summer would represent warmer temperatures. In the wintertime, notice the dissolved oxygen is very high in our graph. In the summertime, notice that the dissolved oxygen is much lower. In your head, try to make a sentence of this. As the water warms, what happens? Well, hopefully you're thinking that as the water warms, the amount of dissolved oxygen actually decreases.